Hello, everyone. Today, I would like to give you a lesson on the topic vectors.
Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that.
So, what do we call vector? A vector is a directed segment, i.e., a geometric quantity characterized by a numerical value, length, and direction. Here are these interesting vectors in front of you. So, how can we add vectors? There are two rules, the triangle rule and the parallelogram rule. How to apply the triangle rule? Set aside the first vector. Start at any point and set aside the first vector. Let's call it A. Set aside the second vector. From the end of vector A, set aside the second vector, B. Construct the sum vector. The vector that connects the beginning of vector A to the end of vector B is their sum. Let's call it C. Obtain the triangle. Vectors A, B, and C form a triangle. Steps for adding vectors using the parallelogram rule. Set aside vectors. Mark a common starting point, for example point A, and set aside both vectors, for example vector A and vector B on it. Construct a parallelogram. On the constructed vectors A and B, complete the parallelogram. Determine the sum. The diagonal of a parallelogram, which originates from the common origin of vectors A and passes through the opposite vertex of the parallelogram, is the vector sum of the vectors A plus B. But how can we perform the inverse operation, subtraction? Step by step, following the head-to-tail rule. Reduce the vectors to a common origin. Set aside vectors A and B so they have the same origin. Determine the difference vector. Join the end of vector B to the end of vector A. The vector that goes from the end of B to the end of A is the difference vector, A minus B. How can we find the coordinates of a vector? We just need to subtract the coordinates of the beginning of the vector from the coordinates of the end of the vector. In our case, this is subtracting the coordinates of point A from the coordinates of point B, and we get that the coordinates of vector AB are equal to x2 minus x1, y2 minus y1, z2 minus z1. How can we find the length of a vector? According to a formula that is similar to the formula for finding the length of a segment, just pay attention to how we write the length of the vector in the formula. And so let's consider the actions on vectors. If we are given their coordinates, we can add, subtract, and multiply them. But first, let's analyze the action of adding and subtracting vectors if their coordinates are known. So to add vectors with given coordinates, we must simply add their coordinates, and that's it. Step by step, please pay attention to this. And to subtract vectors with given coordinates, we must subtract their coordinates, and that's it. If you understood it, good. Let's find out how we can calculate the dot product of vectors. There are two variants. It can be calculated as the sum of the products of the corresponding coordinates of the vectors, a dot b equals a1 times b1 plus a2 times b2 plus a3 times b3. Or the dot product of two vectors will be equal to the product of the lengths of these vectors times the cosine of the angle between them. A dot b equals a times b times cosine of alpha. Vectors that lie on parallel lines are called collinear. They can be the same length, they can be different lengths, they can have different directions, but they must lie on parallel lines. And even if you see that a green and a white vector lie on the same parallel line, they will still be collinear. Please remember that collinear vectors always have proportional coordinates, and there are certain types of collinear vectors. They can be co-directed, and they can be oppositely directed. Two vectors are called equal if they have the same length, are collinear, and are co-directed. Pay attention to this definition. There are also opposite vectors in geometry. These are vectors that have the same length, are collinear, but are oppositely directed. And that's it. If they are oppositely directed, then we write that vector A is equal to vector negative C. Next.
Perpendicular vectors are two non-zero vectors that form a 90-degree angle with each other, and their dot product is 0. And the cosine of this angle, y, will be 0 because the cosine of 90 degrees is 0. Problem 1. Determine the unknown quantities using the given data. And so we have a vector, its coordinates of the end of the vector and the beginning are given. Similarly, according to the formula, we subtract the coordinates from the end of the vector, the coordinates of the beginning of the vector. And we have that the coordinates of the vector AB are equal to -1, 2. In the second picture, we are asked to find the length of a vector. Well, using the same formula to find the length of a vector, we substitute 2 instead of x2 minus x1. We substitute -3 instead of y2 minus y1. And instead of z2 minus z1, we substitute 6. And we will have that the length of this vector is the square root of 49. And the square root of 49 equals 7. Problem 2. And so we have these vectors BAC1, C1, B1 in order. I highlight them in green. And here we see a smiley face, which is wondering how to depict this vector whose coordinates are given to us, which is the sum of the corresponding vectors. And it will start at point B and end at point B1, because we remember the triangle rule. The length of the height of the prism is the length of BB1. We find the length of this vector according to the given coordinates, and we get that the length of vector BB1 is equal to 17. Problem 3. And so we are asked to find the scalar product of vectors using the given data. Well, in the first picture, we are given the lengths of vectors A and B, and it is also given that the angle between them is 60 degrees. Well, so let's recall the formula for finding the product of vectors through cosine of the angle between them. So we have all the necessary quantities. Instead of the length of vector A, I will substitute 5. Instead of the length of vector B, I will substitute 6. Instead of the angle y, I will substitute 60 degrees, and we will have that the cosine of 60 degrees is 1/2. So our answer will be 15. Well, in the second picture, we are simply given the coordinates of the vectors, so we recall the formula for finding the scalar product through the sum of the products of the coordinates of the vectors. So we substitute instead of A1, -5, instead of B1, 3, instead of A2, 0, instead of B2, 7, instead of A3, we substitute 2, and instead of B3, we substitute -6. After substitution and calculations, we have that their scalar product is equal to -27. Problem 4. The base of a quadrilangular pyramid PABCD is a square ABCD, the diagonals of which intersect at point O. Product of vectors AO and OP equals 42. Determine the area of the base of this pyramid. Solution. So first I select these vectors AO and OP and select the angle between them. Alpha, let it be. Then we recall the formula for finding the product of vectors through the cosine of the angle between them. So we substitute instead of A, AO, and instead of B, we substitute AP, and instead of the cosine Y, I substitute cosine alpha. And by the condition of the problem, the product of these two vectors is equal to 42. Then we must recall the definition of cosine, which is the ratio of the adjacent leg to the hypotenuse, and I will highlight the right triangle AOP in yellow because we will need it now. Cosine alpha will be equal to vector AO divided by vector AP. Then we must substitute instead of cosine alpha into our formula, we must substitute this ratio AO to AP. And we have, after reductions, we have that the length of the vector AO squared is equal to 42. Hence, the length of the vector AO will simply be the root of 42. And AO is half the diagonal of the square ABCD, is a square, because the base of a regular quadrilangular pyramid is a square. So AC will be twice as long as AO, so AC will be 2 square roots of 42. Next, I mark in blue the diagonal of the square that we just found, and marks the sides of the square by A, because the sides of a square are always equal, and the sides, therefore, by A, I marked them. And now in the Pythagorean formula, we can substitute instead of A and B, simply A, and instead of C, 2 square roots of 42. We have that A squared is equal to 168. And A squared is exactly what we were asked. This is the area of the base of this pyramid, so 84 is our answer. So if you understood everything today, I would give you History Supreme Yacht as a gift. If you are worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up, and I wish you to understand it as soon as possible. Bye!